going to be the biggest angle because the rest of the 90 degrees in the triangle have to be split among those two angles. So we have 15 centimeters. And it says, and one angle, okay, a right angled triangle has a hypotenuse of 15 centimeters and one angle that's x radians. We're going to say this one's x radians, okay? And we don't know what the other one is. So I'll put a question mark, okay? And then, let's see. Part A says, find an expression for the perimeter of the triangle in terms of x. Okay, so perimeter is going to be the sum of the lengths of all the sides. So we know that one of them is going to be 15. You all probably got that part. Okay, so now we need to figure out the length of all of the other sides. So remember that we can solve for this using our trig functions. So this is basically using SOHCAHTOA. Let me see if this is what I did from before. Yeah. Okay, so sine of x, which is going to be this guy, is going to be equal to, let's name the sides A and B, okay? So sine x is going to be equal to the opposite over the hypotenuse, so A over B. Cosine of x is going to be the adjacent over the hypotenuse. Oh, the hypotenuse is 15. Silly me. A over 15. The cosine is adjacent over hypotenuse. The adjacent side is B, so we're going to put B over 15. And I think that that's all we need. So we can solve for each A and B in terms of the x radians in the 15. So A is going to be equal to 15 sine x, and B is going to be equal to 15 cosine x. Okay. And then, okay, so then let's see, what did it want us to do? Oh, in terms of x. So the key word here in terms of x just means that we have x in our equation. So I can just add on, so my perimeter is 15 plus a plus b. Then I solve for a and b in terms of x, both here and here, so I can sub those in. So 15 plus 15 sine x plus 15 cosine x. Then it says find an expression for the rate of change in perimeter as x varies. So if you imagine we have a triangle and like that angle is like constantly changing size, then our side lengths are going to change size with it. Okay, so we can write a function, a differential equation, to show how that change occurs. So in part B, all we're doing is we're taking the derivative of p. Okay, or we could say, if you wanted, dp dx, we're changing the perimeter, d stands for the change, with respect to the change in x, okay, where x is our radian measure. So the derivative of 15 is 0. The derivative of 15 sine x is going to be 15 cosine x, and the derivative of 15 cosine x is negative 15 sine x, okay? So my final answer would be 15 cosine x minus 15 sine x, okay? And then it says, hence find the value of x when this rate of change is greatest. So the rate of change is greatest. Oh, let's see here. Okay, so greatest rate of change means that P prime has to have, oh, sorry, everything is falling, a max or a min. Okay, so we're looking for the largest amount of rate of change. So I'm going to bring it to part C down here, and I think I wrote this on the other thing, greatest rate of change. Okay, so this is kind of the same as what is in the problem, just reworded a little bit. We're looking for the greatest rate of change, and this means that we're looking for a max or min of the function that changes perimeter as we go. So we're looking for the max of P prime or dp dx. Okay, we're looking for the maximum rate of change that we can get. Okay, so basically we need to find P double prime of x and set it equal to 0. Okay, because this will tell us when we've hit the stationary point on P prime. Okay, so when we take our second derivative, so P double prime of x should be equal to negative 15 sine x minus 15 cosine x. Is that what I got? Yeah. Okay, and we're setting that equal to 0. So I'm going to go ahead and factor out just the negative 15 from both. So we get sine x plus cosine x. Okay, and then we can divide both sides by the negative 15. Okay, so we still get 0 equals sine x plus cosine x. And then we can subtract cosine from both sides. So negative cosine x equals sine x. Okay, and the only places where this happens on the unit circle, when cosine and sine are equal, those are the multiples of pi over 4. And there's specifically the two in the quadrants where the x and y values have opposite signs. So they're going to be 3 pi over 4 and 7 pi over 4. Okay, so those are our two possible values. And so now we have to check and see which one has the greatest rate of change. And so in this case, we have to take them and sub them into P prime. Was this calculator active? I don't know, I did it all the way out on the paper. I'll just copy my answers from before because it's a lot of work. So we have 3 pi over 4 and P prime of 7 pi over 4. When we had P prime of 3 pi over 4, you get negative 15 root 2. And then 7 pi over 4, you get positive 15 root 2. So this one has to be the greatest. Okay, so this would be our solution. So x, I guess, equals 7 pi over 4 is our greatest possible rate of change. Okay, I think that is all. I hope that helped make this make a little bit more sense. I see why you guys picked those two problems. I will scan this and upload this so you'll have it. Yeah, I guess that's it for today. I hope you guys have a great day and that the test is just not that bad, not stressful. That was the goal. It's definitely not as long as the other tests. So good luck, and I miss you all, and I hope you have a great day. I think I said that about 8 times now, so I'm going to stop. All right, bye everybody.